laws of reflection. Why do mirrors have a silver coating on one side of the glass? It is because highly polished metal surfaces reflect light when it is incident on them. In this animation, we will learn about the reflection of light on a plane mirror, what governs the reflection of light, and how images are formed in a plane mirror. Let's assume XY to be a plane mirror coated with silver coating on the underside. Let a ray of light AO be incident on XY. The light is reflected along OB. Let's now draw a normal ON at the point of incidence. The angle AON formed by the incident ray and the normal is called the angle of incidence, or I. The angle BON formed by the reflected ray and the normal is called the angle of reflection, or R. Observations from experiments have shown that the incident ray, the reflected ray, and the normal drawn to the reflecting surface at the point of incidence all lie in the same plane. Also, the angle of incidence is equal to the angle of reflection. These observations are called the laws of reflection. Let's now see what is angle of deviation and how it is related to the laws of reflection. Consider a ray of light AO incident on a plane mirror XY, which is silver coated on the underside. The light is reflected along OB. Let's mark the angle AOX as alpha. This angle is called the glancing angle. According to the laws of reflection, the angle of incidence is equal to the angle of reflection. Hence, the angle BOY can also be marked as alpha and can be called as the glancing angle. When light is reflected from a mirror, it is deviated from its original path. Here, the original path can be marked as OC. This means that the angle AOX or BOY or alpha is equal to the angle COY. From these observations, we can conclude that the angle COB is equal to 2 times alpha. The angle COB is called the angle of deviation, or D. Since D is equal to 2 alpha in general, we can say that the angle of deviation of a ray by a plane mirror is twice the glancing angle. We all know that an object placed in front of a mirror will form an image behind the mirror also. Let's now learn about the image formed by a plane mirror. Let's consider a plane mirror M placed vertically. Let a ray of light AO fall on M and reflect along OB. The normal ON can be drawn to the mirror at O. According to the laws of reflection, the angle of incidence AON is equal to the angle of reflection BON. Assume that another ray AD is incident normally on the mirror at D. This ray will reflect back along DA. If we join the lines BO and AD backwards, it will meet at I, which is the backside or the underside of the plane mirror. This explains why rays reflected from M appear to come from behind the mirror. We can observe that the angle AON is equal to angle DAO as they are alternate angles. Also, the corresponding angles BON and DIO are equal. This implies that the angles DAO and DIO are equal. Hence, the triangles ODA and ODI are congruent. This also implies that AD is equal to DI and AO is equal to OI. From these observations, we can conclude that an object and its image in a plane mirror are at equal perpendicular distances from the mirror. Let's recapitulate the key points covered in this animation.
Law of reflection. Light rays bounce off shiny surfaces, such as that of a mirror, in a phenomenon known as reflection. Plane mirrors, named as such because of their flat surfaces or plane, have distinct ways of reflection. The ray approaching the mirror is known as the incident ray, and the ray bouncing off is known as the reflected ray. When calculating angles related to reflection, it is customary to measure the angles from an imaginary line, which lies perpendicular to the plane of the reflecting surface and is known as the normal. The law of reflection states that the angle of incident light is equal to the angle of reflection. If we were to place a lighted candle in front of a plane mirror, infinite rays of light would be reflected in all directions. After striking the mirror, the rays will reflect at angles equal to their angles of incidence. In this case, the incident ray forms an angle of incidence or theta I, and the reflected ray creates an angle of reflection or theta R in relation to the normal. According to the law of reflection, theta I is equal to theta R. In mirrors, the incident ray, the normal, and the reflected ray all lay on the same plane. This law applies not only to plane reflective surfaces, but also to convex and concave reflective surfaces. Summary. The law of reflection states that the angle of incidence of the light rays striking a plane mirror is equal to the angle of reflection.
Do you know how an image is formed when an object is placed in front of a mirror? Let's learn about the science behind mirrors and mirror images. We already know that an object becomes visible only when light from that object enters our eyes. That light may be the object's own light, or it may be the light reflected from other luminous objects. For example, we are able to see these fruits in the bowl because light from the lamp falls on the fruits and is reflected into our eyes. In the same way, when a candle is lit in a darkened room, we are able to see it because light from the candle enters our eyes and makes it visible to us. If we place a plane mirror in front of this candle, we not only see the candle, but we also see an image of the candle in the mirror. Let's learn more about how this happens. Now remember, a plane mirror is a mirror that has a flat surface. Light rays striking a plane mirror are reflected in such a way that the angle of incidence is equal to the angle of reflection. Both these angles are measured relative to a normal drawn to the surface. The incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. For a ray incident normally on the mirror, the angle of incidence is equal to 0. Therefore, the angle of reflection is also equal to 0. This is why the ray is reflected back along the same path. Drag the object to change the angle of incidence and observe how the angle of reflection changes. Now, coming back to the candle. When light rays from the candle strike the mirror, they are reflected from the mirror and enter your eye. You will then see an image of the candle in the mirror. Reflected rays from the mirror appear to come from behind the mirror when traced back. That is why the image appears to come from behind the mirror. This is what is called a virtual image. The image is called virtual image because reflected rays don't actually meet to form an image. A virtual image is not a real image. It cannot be captured on a screen in the way that an image from a projector can be captured. If you look carefully, you'll see that the reflected image is of the same size as the object and is also formed at the same distance behind the mirror as the object is in front. Light rays are reflected from a plane mirror in such a way that the angle of incidence is equal to the angle of reflection. This is why the image formed in a plane mirror is always laterally inverted or appears to be reversed from left to right. We've just learnt that the image formed by a plane mirror is virtual, upright, the same size as the object, the same distance behind the mirror as the object is in front, and laterally inverted. Now that you've learnt some of the laws of reflection related to plane mirrors, check your understanding with this quick quiz. That's right. An object is That's right. That's right. That's right.
Image formation in plane mirrors. A mirror is a polished surface that reflects light waves. A plane mirror is flat, like a geometric plane. When a ray of light strikes a plane mirror, the direction is changed so that the ray passes back in the direction from which it originated. If we draw an imaginary line, referred to as the normal, which runs perpendicular to the plane mirror, the angle created between the incoming ray and the normal will be the angle of incidence. The angle created between the reflected ray and the normal is the angle of reflection. The law of reflection states that the angle of incidence will be equal to the angle of reflection. When we tilt the mirror at an angle theta, the reflected ray will rotate through an angle of 2 theta.
If we place a lighted candle in front of a mirror at a distance of x, we will see an image of the candle at a distance of x, seemingly behind the mirror. Image is virtual, will be upright, and cannot be captured on screen. Let's look at the mechanism of the image's formation. The rays from the candle will strike the mirror's surface at different angles and be reflected. If we projected the reflected rays behind the mirror, they would converge at a point, forming a virtual image. The distance between the virtual image and the mirror will be the same as that of the distance between the object and the mirror. Although it is upright, an image in the plane mirror will be laterally inverted. To check this, let's hold the word ambulance in front of a mirror. The word will appear reversed. It is for this reason the word is reversed when painted on the front of emergency vehicles. It can be read correctly in the rear view mirror. A plane mirror will produce an image that is virtual, upright, and the same size as the original object. It will also appear at the same distance as the object is from the mirror, but it will be laterally inverted. Summary: a mirror is a polished surface that reflects light waves. A plane mirror is flat, like a geometric plane. A plane mirror will produce an image that is virtual, upright, and the same size as the original object. It will also appear at the same distance as the object is from the mirror, but it will be laterally inverted.
Diffraction of light through a prism. Refraction is the phenomenon of bending of light rays from optically rarer medium to denser medium. A prism is a triangular transparent optical device. When we shine a beam of light on one face of the prism, the light ray that strikes that face is called incident ray. Let's draw the normal, an imaginary line perpendicular to the face of the prism. The angle between the incident ray and the normal is called the angle of incidence. Inside the prism, the light ray will bend towards the normal at an angle and will continue to strike on the other face of the prism. The light ray then will emerge out of the second face as an emergent ray, bending away from the normal line. The angle between the emergent ray and the normal is called the angle of emergence. The overall reflection of a light ray through a prism is expressed as the angle of deviation theta. The angle of deviation is the angle between the original incident ray and the emergent ray. The angle of deviation varies with wavelengths of light. When a beam of sunlight is shown through a prism, the light will split into a spectrum on the other side of the prism. The beam of light will slow down at the boundary between air and glass and will bend. The bending will depend on the wavelength of the rays. Red light with long wavelength will refract less and therefore will bend less. Violet with shorter wavelength will refract more and therefore will bend more. This phenomenon of splitting of white light in constituent colors by a prism is called the dispersion of light. Summary. Prism is a triangular optical medium. Light slows down while entering the prism and speeds up while emerging. The bend of the light in a prism will depend on the refraction. White light will disperse into its constituent colors when passed through a prism.